Hello, and in this lecture we're going to be investigating the properties of gradients of parallel lines. So when you have a line that's parallel to another line, there's a common property about its gradient. I'll start off with the kind of a classic example of looking at a line that's parallel to the x-axis. So take this line AB is parallel to the x-axis, so you might be able to tell straight away what the gradient will be, but I'm going to do an example so it's a bit clearer. So we take we're trying to work out the gradient of line AB. That's just our gradient formula, y2 minus y1 all over x2 minus x1. So from here, so that's our x1, y1, x2, y2. So here it's 3 minus 3 from our y, and then that's 5 minus 2 for x. So 3 minus 3 is just 0, and then 5 minus 2 is just 3, but 0 over 3, 0 divided by 3 times is just 0. So the gradient you can see here that the gradient of this line is 0, but it makes sense because if gradient is the change in y over the change in x, you can see here it's a straight line and the y coordinate doesn't change at all. So it's not surprising that this comes out to be 0. But this is but what about if you take a example like the y-axis? How would this be different? Okay, boom. So the y-axis, again, we'll start with our gradient formula. So m of CD, which is this line here, this vertical line that's parallel to the y-axis, equals y2 minus y1 all over x2 minus x1. Let's plug these numbers in. So you have minus 6 minus minus 2 all over minus 4 minus minus 4. So that equals 2 minus 4 over 0. And now you can't divide by 0. You can't divide by 0 because it just doesn't make sense. You can't share 4 0 times equally because you're not sharing it at all. So it just doesn't work, basically. So what we say here is the gradient is undefined. And that gradient CD is undefined. But what about if you have two lines that aren't parallel to either the axes, but they're actually parallel to each other? What would their relationship and their gradients be? So we'll just work these out again. MAB equals 6 minus 4 all over 3 minus 2, 3 minus 1 even, 3 minus 2, that's right, equals 2 over 1, just equals 2. So gradient MB is 2. And what about CD? MCD equals 12 minus 2 all over 6 minus 1 equals 10 over 5, which equals 2 as well. So you can see here that the gradient of these two lines is exactly the same. So when two lines are parallel to each other, it means that their proportion of how their y changes with x is exactly the same. So you can see here, this is a little applet that shows you the relationship between two parallel lines. And you can see, as I was saying, if you move these lines around, you can see that as the two lines are parallel to each other, the gradient's always going to be the same no matter what angle you make it at. And if we take it to 0, you can see that the gradients are 0. And I'll attach this down below so you can have a play with it and have yourself. But hopefully this kind of gives you a more kind of visual representation of the parallel lines.